On this RAM, P0072 means the PCM may be seeing the ambient air temperature sensor circuit pulled lower than expected. In plain language, the outside temperature signal can look too low to the module. The MIL may illuminate, and the outside temperature information may be incorrect or unstable. Possible fault areas include the sensor connector, a signal circuit short to ground or to the sensor ground circuit, an open or high-resistance return side, the ambient temperature sensor itself, or a possible module issue after the wiring and connectors are proven good. If other related codes are present, check what they mean first, but keep this diagnosis focused on the P0072 low circuit path. Before getting deep into circuit testing, start with the basic system checks. Look for any service bulletins, case information, or flash updates that apply to this code or symptom. Then check the ECU for any battery voltage codes, because low battery voltage can cause a DTC and send you in the wrong direction. If circuit faults and rationality or performance faults are present together, diagnose the circuit faults first. Next, inspect the component connector at the ambient temperature sensor before unplugging it. Make sure it is fully seated and locked. Then disconnect it and look closely for water intrusion, pushed-out terminals, spread terminals, corrosion, heat damage, or anything burnt or damaged. A poor connection here can look just like a sensor or module problem, and failure to complete the wiring checks can lead to unnecessary parts replacement. Now read and record all codes and the captured operating data, and save a vehicle scan report if you may need it later. Review the captured conditions and the monitor conditions, then clear the codes and operate the vehicle or system to try to duplicate P0072. If the code returns or the condition is present, continue testing. If it does not return, treat it like an intermittent fault and try to reproduce the captured conditions instead of guessing. For this style of temperature sensor circuit, a voltage reading above approximately 4.9 volts would set a circuit high/open fault, and a voltage below approximately 0.10 volts will set a circuit low fault. On the P0072 low side, the threshold is typically in the 0.1 volt range. The high side fault threshold is typically in the 4.9 volt range. Performance monitoring is a different gate. It runs with the ignition on after an 8-hour cold soak on the previous engine off cycle, with ambient air, intake air, and engine coolant temperature values above -64 degrees C, -83 degrees F. A performance fault is typically not within 10 degrees C, 15 degrees C, 18 degrees F, 27 degrees F of the other engine temp sensors, so keep that separate from the low circuit diagnosis. For an intermittent, verify the failure mode is actually present before condemning anything. Some temperature sensor rationality faults can require extended cold soaks, so check component or system operation before trying to force a diagnosis. Recheck for flash updates and service bulletins before spending time chasing wiring. If nothing applies, check the battery or batteries for proper charge and operation, verify proper connections and related grounds, and inspect the component, module, and inline connectors for pushed out, corroded, spread, burnt, or broken terminals. Then wiggle test the harnesses that carry this circuit while watching scan data for the code to become active or the value to move. If you have a scope available for an intermittent low or high circuit fault, backprobe the temperature sensor signal circuit and monitor the circuit voltage while wiggle testing the harness. If you cannot watch the scope live, set a trigger to catch the event. Voltage above 4.9 volts for an intermittent circuit high fault, or below 0.1 volts for a circuit low fault. A clean way to test the whole circuit is to use the electrical test lead kit at the temperature sensor connector, connected to the temperature signal and sensor ground circuits. This checks the ECU, the signal circuit, and the sensor ground circuit together to determine whether the temperature sensor is faulty. Switch the tool between open and closed while watching the scan tool. The voltage should be 5.0 volts when switched to the open position, and 0.0 volts when switched to the closed position. Then move the switch to adjust and use the tool to vary resistance while monitoring the ECU signal voltage. If both open and closed responses are correct, the wiring and module side are testing good, so focus back on the sensor and its connector before making the sensor call. If the signal stays low, or only the low circuit fault sets during the simulation, the likely direction is a temperature sensor signal circuit shorted to chassis ground or shorted to the sensor ground circuit. Check the signal circuit for that short. If the signal is stuck high, or only the high side fault sets, the likely direction is an open or very high resistance in the signal circuit or sensor ground circuit. If the scan tool still shows voltage in the closed position, move the ground side test lead to a good chassis ground. If the voltage drops to 0 volts, the resistance is in the sensor ground circuit. If voltage is still present, the resistance is in the signal circuit. Typically, it should be less than 3.0 ohms. If the circuits check good, inspect every related connector for pushed out, spread, corroded, or dirty terminals before blaming the ECU. If you are using a DVOM, first confirm the temperature sensor and ECU connectors are connected and locked properly. Turn the ignition on, backprobe the temperature sensor signal circuit at the sensor connector, and measure the voltage. If the signal voltage is reading between 0, 1 and 4.9 volts, it is usually a believable sensor signal. For P0072, pay close attention to a constant 0 volts with a low circuit fault. That points toward the signal circuit being shorted to ground, shorted to the sensor ground circuit, or possibly a faulty sensor. If the signal reading has a constant voltage above 6.0 volts, that points toward the signal circuit being shorted to another voltage supply. When the voltage test points to a circuit issue, disconnect the temperature sensor and ECU harness connectors and check the temperature sensor signal circuit for high resistance and for a short to ground. If the signal circuit checks good, inspect all connectors in the system for pushed out, spread, corroded, or dirty terminals before condemning an ECU. To check the temperature sensor side, move the test lead over and backprobe the temperature sensor ground circuit at the temperature sensor harness connector. For a typical active circuit load diagnosis, disconnect the temperature sensor connector while watching for the circuit high fault to become active on the scan tool. This is a quick way to eliminate the sensor as a possible cause with an active low fault. If the high side fault becomes active when the sensor is unplugged, the temperature sensor is most likely faulty. If it does not, isolate the circuit by disconnecting the ECU connector and checking the temperature signal circuit for continuity to both chassis ground and the sensor ground circuit. If continuity is present to either one, repair the signal circuit for the short. If the signal circuit is not shorted, go back through the connector inspections before making a control module decision. Even though P0072 is the low circuit code, your testing may force you to prove the high or open side of the same sensor circuit. For a typical circuit high check, disconnect the temperature sensor connector and measure the temperature sensor signal circuit voltage with the ignition on. The signal circuit voltage should be between 4.9 and 5.6 volts. With an active fault, monitor the scan tool and connect a jumper across the terminals with the ignition on. Typically, the temperature sensor signal voltage should change to 0 volts on the scan tool with the jumper in place. If voltage data is not available, watch for the circuit low fault to set with the jumper in place. Then check resistance of the temperature sensor signal circuit and temperature sensor ground circuit. Typically, the circuit resistance should be less than 5.0 ohms. For performance, rationality, or hard-to-duplicate intermittent checks, disconnect the temperature sensor connector and connect the electrical test kit leads to the temperature sensor harness connector. Move the switch on the tool to open. The signal should read 5.0 volts and a circuit high DTC should be active or pending on the scan tool. Next, flip the switch to the closed position. The signal should read 0 volts and a circuit low fault should be active or pending. If there is voltage present between 0 and 5.0 volts with the test tool in the closed position, there is likely resistance in one of the circuits. To separate the circuits, Remove the test lead connected to the temperature sensor ground circuit and connect it to a good chassis ground. Then isolate the suspect circuit and measure resistance between the sensor and ECU harness connectors. If no resistance is measured, carefully check the connectors in that circuit path for spread, dirty, or corroded terminals before deciding whether the issue is the temperature sensor or ECU. If a temperature table is available, move the switch to adjust, connect an ohmmeter to the test leads, and dial the tool to a resistance value in the table. Connect both leads to the temperature sensor harness connector with the ignition on. Then monitor the scan data for the proper reading while varying resistance and watching the temperature sensor signal temperature or voltage. If the actual temperature can be acquired or reasonably estimated, measure resistance across the sensor terminals and compare it to the table. The actual resistance can vary +/10% form the values in the table. The table points include -40 degrees C/40 degrees F/345, 26 k ohms, -10 degrees C/14 degrees F/53, 38 k ohms, -5 degrees C/23 degrees F/40, 89 k ohms, 0 degrees C/32 degrees F/31, 56 k ohms, 5 degrees C/41 degrees F/24, 55 k ohms, 10 degrees C/50 degrees F/19, 24 k ohms, 15 degrees C/59 degrees F/15, 22 k ohms, 20 degrees C/68 degrees F/12, 13 k ohms, 25 degrees C/77 degrees F/9720 ohms, 30 degrees C/86 degrees F/7780 ohms, 35 degrees C/95 degrees F/6370 ohms, 40 degrees C/104 degrees F/5200 ohms, and 150 degrees C/302 degrees F/181 ohms. If the reading matches the table during harness side simulation, or if the sensor resistance is not in range of the table, the temperature sensor is likely faulty. The temperature sensor is individually serviceable, so if measured resistance does not meet the table values, only the sensor should be replaced and not the entire mirror assembly. If a temperature table is not available for the sensor being tested, connect the electrical test kit leads to the harness connector and flip the switch to adjust. With the ignition on, monitor the scan tool data and slowly adjust resistance in the circuit. The temperature or voltage value should change as resistance changes. If the value changes while resistance is varied, that points toward the temperature sensor being likely faulty. If testing starts pointing at the ECU, slow down and prove it. Open and short the circuits as the test requires, then watch the signal voltage and the fault response. If the expected voltage readings or expected faults do not occur when opening and jumping the connector, and the circuits are not shorted or open, then a faulty ECU is indicated. But before condemning it, carefully inspect the full connector path again for water intrusion, spread terminals, pushed out terminals, burnt terminals, or corrosion. Keep verification separate from the testing. After the repair, clear the codes and operate the vehicle under the right conditions to confirm P0072 does not return. If the ambient temperature sensor wiring was repaired, the sensor was replaced, or the BCM connector was disconnected during testing, the vehicle must be driven for a minimum of 5 minutes above 15 mph to update the temperature signal before the DTC will go stored and can be erased. The takeaway on P0072 is simple. Prove whether the low signal is coming from the sensor, the connector, or a shorted circuit before you blame the module. Do the connector checks early, simulate the circuit when you can, and verify the code stays gone at the end. For more diagnostic training, visit stepdiagnostics.com.